All right. Well, good morning, good afternoon, good evening, wherever you are in the world. I'm glad that you can be here with me today. My name is Micah Silverman, and I'm going to do a little live hacking session with you this morning called Stranger Danger. Your JavaScript attack surface just got bigger. Now I'm going to glance off to the left or right. I'm not sure how it's mirrored occasionally to look at the chat. So please feel free to drop anything in chat if you have questions. And I'd love to hear where in the world you are joining from today. I'll drop in. I am in North Carolina, US. So go ahead and drop into the stream where you're joining today. I'd love to hear that from you. And in the meantime, let's press on with just a little bit of background about me. My name is Micah Silverman, as I said, and I've been a Java developer for 27 years since it was released in 1995. I also got to co-author this book called Mastering Enterprise Java Beans just in time for that technology to be irrelevant. But it's still something that I'm very proud of. I'm an open source contributor. I'm a DevSecCon chapter leader. If you don't know what DevSecCon is, it's a standalone organization that brings developers and security professionals and DevOps professionals together from all over the world. And I started the first US based chapter in Virginia. And the cool thing is that our sessions are always hybrid. So you can drop into a session from the UK or from Germany or from Virginia, in my case, wherever you are in the world. I'm a tinkerer. I like to build these full-size arcade machines. And most importantly, I'm a chaotic neutral in Dungeons and Dragons. And if you don't know what that means, it just means that I like to mess around with people and pull practical jokes and do things that make no sense. Maybe my party is walking through the woods surrounded by monsters and I'll trip one of my party members. It's hilarious to me, maybe nobody else. But the reason I bring it up is because it turns out that that alignment is very useful when we're talking about security and hacking and having the mindset of an attacker, because we can probe around the edges of a system and look for vulnerabilities. But the neutral part in chaotic neutral is that when I do find vulnerabilities, I report it to the right people in the right way because I'm not chaotic evil, I'm chaotic neutral. All right, just checking the chat real quick. We have Bulgaria, Norway, UK. Well, lots of Bulgaria. Awesome. Welcome. Thank you for being here this morning. So let's give a brief overview of what we're going to look at today. We're going to look at the current state of open source security. What are the hot topics? We'll introduce the iceberg. If you have no idea what I'm talking about at this point, that's okay. We'll get to it. We'll do some live hacking with Patch's help. Patch is our little mascot here, our Doberman mascot. And we're going to talk about remediations. It wouldn't be complete if we just talked about issues and vulnerabilities without remediations. And we'll just review what we learned together here. So, current state of open source security. I probably don't have to tell you this if you're a developer, but organizations of all sizes are heavily reliant on many open source components. And open source software has a lot of cybersecurity implications. It's an attractive entry point, and we've seen this multiple times now with things like Log4j. Last December, we had Log4Shell, where on December 9th, everything was right with the world. And then all of a sudden, we had this huge vector of attack because a new vulnerability was discovered and disclosed. And that's really when attackers go to work, is when these vulnerabilities are disclosed, even when there's a quick patch, as there was way back in 2017 with Apache struts. You may have heard of the Equifax breach in the US. That's kind of a cautionary tale because there was a new vulnerability, it was disclosed and it was patched. And something like a quarter later, like 90 days later, the Equifax breach happened because Equifax hadn't patched their software, hadn't updated their software. And unfortunately, that happens all the time. Now, it looks like we might have learned a little something because when Log4j happened, we were very quick to jump on that. It was a very critical vulnerability. And as far as we know, there haven't been any breaches related to log4shell. But the attack surface is changing. It's moving faster from what we saw in traditional cybersecurity threat models, because you have this one vulnerability and multiple places to attack. In the case of Log4j, that library was used in so many different stacks, everything from entertainment to banking, that it really had a great impact. And defects in small libraries can cause systemic risks. And I don't know all the details yet, maybe you do, but we're just now dealing with a new open SSL vulnerability that Sneak just published a CVE yesterday about it, and there was a release yesterday. And so we're kind of in the cycle again of dealing with a new risk, and hopefully we'll continue to learn the lessons so that there aren't any breaches related to it. So why do we care about application security? If you're like me as a developer, in the past, even with a security mindset, I worked for big banks and insurance companies where developers did development, security team did security. Well, when OWASP looked at the Open Web AppSec project, looked at 85,000 apps, 83% of them had at least one security flaw. And 20% of those, so that's 1 out of 5, were severe vulnerabilities, the kinds of things that could be exploited, compromised machines, etc. So let's have a look at some of the open source software attacks that we see, especially through the lens of JavaScript. You may have heard of typo squatting attacks. So this is a scenario where bad actors push malicious packages to a registry, hoping to trick users into installing them. If you accidentally double type the same character, or sometimes it'll be common misspellings or reversed letters, or letters that might be near the letter on a keyboard. And so then in this case, in this example, if you were to npm install React with the double E, it's likely that it would seem to be behaving like you would expect. I'm writing a React app. It's working the way I expect because an attacker has taken the real React package and just embedded some malware in it. So then you distribute your library, or you distribute your application, or you have it live on a website, and now anybody that goes to that website, maybe this malware, this is a real sort of this is a real world scenario that's happened, where the malware is looking for a crypto wallet on your machine and trying to steal crypto from you. So maybe 90% of the people that get infected with this typo squatted package, it has no effect on, because they don't have that crypto wallet. But for the people that do, all of a sudden they're getting their crypto siphoned off. Another one is injecting malicious code into a software product. So there's a popular game called Fall Guys, and this is a real world scenario. There's this package called Fall Guys. Let's see if I have it up here with me. Bear with me a sec here. We'll tempt the demo monster and see if I say Fall Guys. I gotta spell it right. This is a tool called Sneak Advisor. We're going to come back to it, but what I'm looking for is this. So Fall Guys is just a straight up malicious package. It served no other purpose than to do malicious things, but it was related to this popular game, and so people were being tricked into installing it. Then we have my favorite from the chaotic perspective, but it's a bad one from the security perspective, and that's compromised maintainers. And this little graph may be hard to see, but it's important to note that EventStream was the primary package in this scenario. But what really was affected was this dependency of EventStream called FlatMapStream. And FlatMapStream, because that was a dependency, when EventStream, a version of EventStream was released that relied on FlatMapStream, and then an infected version of FlatMapStream was published to the ecosystem. And what that meant is that the next time that you were to update EventStream, it would have pulled along this infected version of flat map stream with it. So this one's particularly tricky because it involves a dependency of a dependency, and it makes it harder to catch. So just in case you think you're safe, these are all JavaScript examples. Supply chain attacks affect all ecosystems. I spoke about Log4Shell a little while ago. That was the Java ecosystem. We've seen supply chain attacks in all these ecosystems: Python, PHP, Docker, Kubernetes, things not pictured here. It affects all ecosystems. All right, let's introduce the iceberg. Maybe you've seen this before, but the iceberg, as it turns out, is a really great metaphor. It maps onto modern application architecture in a way that is useful for us to look at through the lens of security. What do I mean by that? Well, we know probably from grade school that the tip of the iceberg is the smallest part of the iceberg. It's the part that's above the surface, that's visible. And we can say that that's our app code. The smallest part in a modern application is the custom code that you're writing. So if we look at this code on the screen here, there's a problem with it, and maybe you can spot it. And if you do, just drop it into chat. I'll glance off here and take a look at the chat. But can you see a problem with this code just at a glance? Anybody care to drop it into chat? Don't be shy. I'll give it another 5 seconds. All right, so there's a couple issues here. The primary issue that we're looking at is we have this request that's coming into the function here, and elements of that request are being passed into another function completely unsanitized. So this is the kind of thing that leads to SQL injection, NoSQL injection. It's the basis for cross-site scripting attacks. So anytime we have unsanitized inputs being passed into another function, that's a problem. Also, there's kind of a subtle implication here, which is that our database is using plain text passwords because we're taking the password that's coming in on the request and passing it directly through to the function. So that's really bad. We don't ever want to be in the business of storing plain text passwords. But once we start to look deeper into our code, we see that very quickly we start to rely on things that are below the surface of our iceberg. So the next layer down on the iceberg is open source code. And we can see here that we're requiring a library called marked. Now we still have custom code here because I'm going to do something with that. But once we have that reference, we're now working our way down the iceberg. This is below the surface. This is the part of our application that's harder to see because it's this open source library that we're now dependent on. Now, for most of us, and hopefully you've had this experience too, open source is a great help. It makes us able to write code a lot faster because if I want to write an application that supports Markdown, I don't want to reinvent the wheel and have to write a Markdown parser myself every time I want to include that feature. I want to use a open source library that's going to help me add that functionality in. But we want to have a high degree of confidence from a security perspective in the open source libraries that we bring in. Now we're going to get to some live hacking in just a second, so I want you to get ready to navigate to a website, make sure that your browser is ready to go. But before we get there, let's take a look at some of the cybersecurity challenges we have. Now the numbers here are it's an average across all languages, and then we have more specific breakdowns for individual languages. But on average, the number of outstanding critical vulnerabilities in an application is 5. And here's something that's striking to me. The average dependencies per project is 80, and we're talking about the entire dependency graph. What that means is that if I have 5 dependencies in my application, and I look at the dependencies of those dependencies, like flat map stream was a dependency of event stream, well, by the time I blow up that whole graph of dependencies, it balloons up to 80 dependencies on average. And here's the biggest one. On average, it takes over a quarter of a year 97.8 days to fix a vulnerability. And that's how we end up in situations like the Equifax breach, where a vulnerability has been discovered, disclosed, and patched, but companies are slower to apply those patches than would be desirable. And on average, we find over 90 days. All right, let's demonstrate this, and let's hack an app together. And I'd like you to go to sneak-chat-goof.sneakchallenge.io. And I'm going to drop this into chat. Bear with me because I should have had this in my clipboard, but I'm typing it live. sneak-chat-goof.sneakchallenge.io. All right, hopefully I did that right. It looks good. And what we're going to do there, you'll see an interface like this. It's not a particularly sexy interface, but I am not a front-end developer, so bear with me there. But you're going to put in a username. It doesn't have to be your real name. And then you'll notice that there's this place called main room. Click on main room and click on start chatting. Now it'll be lonely here if it's just me, so I want you to join me here because we're going to hack this app together. And I have a special prize for anybody that can break this app, but there are ground rules. So I see some people coming in. That's great. But let's talk about the ground rules. You can't use a denial of service attack because this is a very small instance running out there in the cloud, and it would be too easy. I could probably, from my phone, break this app with a denial of service attack. But if you can come up with something clever, some clever JavaScript, or some clever backend API call that crashes this server, I have a special prize for you. Now, what we're looking at here is a chat app. The front end is JavaScript, the back end is Java, and it's using WebSockets to communicate in between. So I can say hello to you all. There you go. And if you noticed, I put in a special character. I put in the pound sign, and that made it big. That's because this chat app supports Markdown. Now, Root, I appreciate what you're doing, and I want to encourage everybody else to do this as well. Feel free to hack around. Feel free to try to inject Java. That's the game that we're playing. Sorry, JavaScript. So do like Root does. Try to figure out if you can inject some JavaScript. And just like Root did here, this is the first thing that I would try as a chaotic neutral to mess around with a site and an application like this. I want to probe around the edges and see if I can get some JavaScript to slip through, because if I'm successful, all of a sudden I'm going to see an alert. But we can see here that there's some level of sanitization because it didn't pass this through as a script tag. It converted it to plain text and then showed it exactly as Root had typed it. So that's good. There's some level of sanitization. Now, I always love when people try this, like the name or 1 = 1. That's a great username. Keep doing stuff like that. I love everything that you're trying. All right, in case you're not familiar with Markdown, Markdown supports links. So bear with me a sec. I'm going to type in this link. Here we go. Now, a Markdown link is a set of square brackets followed with a label inside, followed by a set of parentheses with a URL inside. And that ends up being a link. And that's kind of handy for a chat app, right? This is a good use case. And one thing I want to warn you of is that Markdown does not support opening a link in a new tab or a new window. It's kind of a shortcoming of Markdown. So if you click on this link, it's going to take you away from the chat app. What I'm going to do instead of clicking on the link is I'm going to right click and I'm going to say open link in new tab. And we can see that it's just a regular old link, right? So from the perspective of a chat app, that's kind of handy. And by the way, our username S, tried to drop in an image tag. That's a good attempt. And by the way, Markdown does support images. Let's keep everything safe for work. Thank you very much. But you can drop images into this. But being able to support links here gives me another vector of attack. Now, this is good. Flip tried something very long and complex here, so I appreciate that attempt. Keep working on it. But being able to support markdown links gives me another vector of attack. So I'm going to try a sneaky link. And now, instead of a URL, I'm going to try this version of JavaScript injection. So now I have a valid markdown link, but instead of a URL, I'm using JavaScript : so that would be like an ahref, where the href is JavaScript : alert1. And because I have this new vector of attack in Markdown, let's see if this is going to work. Now I got to scroll down a little bit, so bear with me here. There we go. So the last thing that I typed here, this Markdown attempt at injecting JavaScript, resulted in a single close paren. So to me, as a chaotic neutral, this tells me that maybe I'm making some progress. Maybe I've damaged the Markdown parser in some way because it kind of gave up. It didn't convert the entirety of what I typed into plain text, but it also didn't inject JavaScript. So I wasn't successful, but I think I'm making progress. All right, so I'm going to try a few more things. I got to alter this app so I don't have to scroll around so much. But let's try another thing, and I'm going to explain what I'm doing here in just a moment. All right, so now I'm trying to get more tricky. What I've done is I've dropped in an HTML entity. If you're not familiar with HTML entities, it's a way to represent characters in the ASCII character set, and your browser will convert it to the character. And this is actually the technique that's used to render things like tags, but not have them interpreted by the browser. So &#58 is the HTML entity for a colon. So what I'm hoping is that I have a dumb sanitizer that maybe is using regular expressions, and this will slip past it. Maybe it's looking specifically for JavaScript : and that'll slip past the sanitizer, but the browser will convert &#58 to a colon, and maybe that'll sneak past the sanitizer. Let's see. I'm scrolling down to the bottom. Y'all are doing great work here. The goodest boy, we ended up with a broken link, but that was close, a broken image. Philip, I think maybe you were trying to do a buffer overflow, and that used to be successful, but I fixed that. But let's take a look at the last thing that I put through, and that you can now see that is empty. It's completely empty. Either the sanitizer has broken or it's given up completely, but now nothing is coming through at all. All right, so I see that. I'm an optimistic person. I see that as more progress. I'm going to do one last thing here, and I want to draw your attention back up here because I'm going to give you a little spoiler alert. This is going to work. So let's see why this is going to work. Now, the reason this is going to work is because of a problem with browsers in general where they're too permissive, and a vulnerability in the Markdown library that I'm using. So if you notice, I've inserted the word this into my HTML entity. Now, &#58 is no longer a valid HTML entity because it's missing the semicolon, but the browser will happily render that as a colon because browsers are too permissive. And then because of a vulnerability in my Markdown library, this is going to sneak past the sanitizer. So let's parse this together from left to right. We have JavaScript, we have a colon, followed by the keyword this. Now, this is a keyword in JavaScript. It's often misunderstood, but it's completely valid. This is just going to be a no-op, and then we're going to continue parsing. So semicolon, that's the statement separator in JavaScript, no problem. Then we have alert1, ampersand pound 41 is a closed paren. I set that up as an HTML entity just for good measure, just in case the sanitizer is looking for nested parentheses or something like that. All right, let's put this through. And then if I scroll to the bottom, you can see now that I have this link, and when I click on it, I get an alert. And it's worse than that. If you click on it, you're going to get an alert, because by the power of WebSockets, this chat message has now been sent to you as well. So this is a classic cross-site scripting attack, and it's a distributed cross-site scripting attack because it affects you as well. And you might be inclined to say, well, what's the big deal? It's just an alert. But like a lot of attacks, this is a foot in the door, meaning once I know that I can do this, now maybe I can craft some more sophisticated a more sophisticated JavaScript payload, and maybe I can exfiltrate your local storage, or maybe I can trick you into displaying your cookies and I can hijack your session. Okay, so from a development perspective, let's look at some of the code here. And you can see that I was trying to be a responsible developer. I'm not going to reinvent the wheel. So I'm importing this library called Mark because I have this chat app and I want to give it this capability to show, to process Markdown. So I add this marked library, and then I read the documentation and I know that I need to set some options. So I'm turning on the sanitizer. That's good. We know that we need to sanitize input so we don't have cross-site scripting issues. So this is 2 lines of code. And then the third line of code is just to say that anytime a message comes in on a WebSocket, pass it into the marked function so that if there is markdown in that message, it will get formatted. It'll get rendered properly and turned into an image or a link or a bold or a large type of text. So in 3 lines of code, I've been able to add Markdown to my application. That's really good from a development perspective, but we've seen that it's not so good from a security perspective. So how do we deal with that? As developers, how can we have a high degree of confidence in the libraries that we're bringing into our applications? Well, I want to start with Sneak Advisor, which I showed briefly before. This is a free tool from Sneak, and it's completely free, meaning you don't have to put in an email address. You don't have to have a Sneak account. It's really free. And if one of the things that you can do is do a search. I'm doing a search for Markdown. So imagine the scenario. I have this chat app. Now I want to add Markdown functionality to it. Now, if you look off to the right here, you'll see that we give it a package score. And you can see some of them are low, some of them are high. There's a lot of results. That's the case with NPM, with JavaScript in particular. For the same type of feature, you'll get a lot of results. But as I scroll down here, I can see that only one of them has 100 out of 100. And that's this marked library. And if I dig into that, I can see that this package health score comes from these 4 dimensions: security, popularity, maintenance, and community. Now, if you're like me, what I used to do in the past is I'd go over to GitHub and I'd look at the number of stars, I'd look at the number of contributors, I'd look at the last release or the last commit to get a sense of how well maintained it was and how big the community was. That's still valid, that's still good, but I didn't really get a sense of the security. So this is getting 100 out of 100 because there are no known security issues with this version of the marked library. So just at a glance, this gives me a very high degree of confidence in this library. Now, you may be saying, well, if marked is so great, how did we just exploit this cross-site scripting issue? And the short answer to that is that I cheated, and we're going to look at that in just a minute. But as we scroll down here, we can see we get more information about different versions, which is the most popular version. And we can see that the latest versions of Markdown or of the marked library have no known vulnerabilities. That's really good. Now, as I said, I cheated, and the way that I cheated is the version of Mark that I'm using for this demo that we just saw is 0.3.5. That is a very old version of Mark. In fact, it was released in 2015, and it was before they even got to their 1.0 release. So, as you might expect, a very old version that wasn't well supported has all of these problems with it. But the latest version has no known vulnerabilities. Now, in addition to using Sneak Advisor, another way that we can get very quick feedback here, and I need to move this out of the way, is to use a browser integration for scanning. Sorry, an IDE integration. What we're looking at here is IntelliJ, but Sneak has IDE integrations for IntelliJ, Visual Studio Code, Visual Studio, pretty much all of the modern IDEs Sneak has a plugin for. And what I can do in tempting the demo monster is I can run a scan on the code as I'm working on it, and I can get feedback on vulnerabilities. And as I said earlier, this is a mixed application. It's Java on the back end, JavaScript on the front end. And so we can see the results that we get back here. The pom.xml is the Java result. The package JSON are the JavaScript results. And we can see that there are all kinds of problems with this version of Mark. So this is a way for me to get feedback very early on in the life cycle and resolve those issues before they ever hit my CI/CD server, or worse, production. All right, let's press on here. So what did we learn? We learned a couple of things. One is that Sneak Advisor is a great way to have a high degree of confidence in the open source libraries that we're using. So we can still move fast as developers. We can still bring in lots of open source dependencies and not have to reinvent wheels. And we can have a high degree of confidence in their security. We also saw that we can scan directly, and I scanned from the IDE, but Sneak also has a CLI tool that you can scan from the CLI, so the command line. So wherever you're comfortable working, Sneak is there to help you, whether it's in your IDE, the command line, the web interface. You can use Sneak to analyze your code and get good feedback. This is a view of the IDE, which we just saw. And I didn't show you yet the web interface, but the web interface gives you this nice roll up. But more importantly than the look and feel of it, the web interface can give you things like more detailed information about the vulnerabilities that are found. And every time there's a vulnerability that's found, there's a link to more information to learning about this type of vulnerability. So if it's a vulnerability that you're not familiar with, you can click a link to learn more about it. Once you import a project into Sneak's web interface, you can also have it automatically create fix PRs for you. And that's super handy because you can still move fast and you can get these automatic PRs, and we'll give you advice on how to merge them. So let's just say, let me just see here if I still set this up right. Okay, good, I did. So when I go to look at the vulnerabilities here, I can see that I have all of these issues. I can see these learn links, and I can use Sneak in my settings to automatically create fix pull requests for me. And that enables me to continue to move really fast. So that's something that's super, super handy. This is just a view of Sneak Learn. If you click one of those vulnerability links, you'll get to an interface like this. And over here, if you're interested and you want to learn more about a particular vulnerability, we kind of take you through a step-by-step tutorial about it. So that is super useful. Okay, let's go back to our iceberg and look at a few more things. Bear with me. I just want to check on one thing here. If we have time, I'll show you a fix PR. let me go and bear with me a second here. I'm going to remove this project, and time permitting, we'll re-import it later just so that you can see what that looks like. But let's move back to our iceberg here. So as we move down, we've looked at the tip of the iceberg, which is your custom code. We spent some time looking at open source vulnerabilities in the libraries that you bring in. As we move down, we start to expand our surface area of attack with containers. And if you're like me, when you think of containers, you tend to think of Docker. That's the first word that comes to mind for me. But we have to think of these other services as containers also. Even Netlify, where maybe we deploy static websites to, we have to consider that as a type of container for our static websites and understand that our attack surface increases when we're using those kind of services. So if you're like me, I tend to think of my application as the code that I write. But we've already talked about how the real footprint of the application has to include the open source dependencies that I've brought into that application. Well, imagine a scenario where I have 0 vulnerabilities in my code, 0 vulnerabilities in my dependencies, my open source libraries, but now I'm deploying my application to a container. And maybe that container has an older version of Linux, or it has a whole bunch of utilities that have known vulnerabilities in it. Well, I've now expanded the surface area of attack beyond my application. So maybe there's an exploit in the runtime, in the Node.js runtime, that has nothing to do with my application. So I want a way to be able to have a high degree of confidence in the Docker files that I'm using in my container configurations, so that I'm not expanding that surface area of attack and introducing new vectors of attack. So here's a typical Docker file. And it's amazing, in 11 lines of code, it's amazing to me what we can do. We can spin up a whole image and a whole virtualized machine and have all these handy utilities running on them and deploy our application to it. But things we want to be mindful of is things like common software. Is the version of ImageMagick that you're using in this example, is that version, does that have known vulnerabilities? Maybe it does. You want to make sure that you're using a version that doesn't. What about your dependencies? One thing you want to watch out for is running npm install in such a way that it installs all the dev dependencies. Because when you're working locally, maybe you're using dev dependencies that have known vulnerabilities in them. And you say to yourself, well, this is just for my local environment. I don't really care so much. But then you accidentally install those dev dependencies in your production environment, and now you have an expanded surface area of attack. So you want to make sure that you're only installing the minimum amount of things that you need to install, like your runtime dependencies and not your developed dependencies. And then how about the runtime itself? What version of Node are you using? Are you using a version that has known vulnerabilities, or are you using a version that has 0 known vulnerabilities? So we can get feedback from Snyk, from the Snyk tool set, about the image that we're using in Docker. And I want to tempt the demo monster a little bit, and let's see if we can get a live version of this. So bear with me a second. I'll make this nice and big. And let's see if I'm in the right place here. Bear with me a second. I think this is the one that I want to look at. So I'm going to run a live container scan here. This might take a moment. So it's analyzing the dependencies of this image, and it's using the Dockerfile as a hint, but it's actually looking at the binary image that I created. And if you notice here, it found 53 issues, and it's telling me that that it's unhappy with my base image, and it's found all these vulnerabilities, right? Now let me bear with me a second, because I'm going to do a different one, which I think will give us some more instructive values here. Bear with me a sec. Sneak container. I think this is it. Oops. Let me build this. Docker build. This is what we call demo monster here. Been a while. Maybe it's Docker compose that I want. I think this is it. Let's see. Nope, I'm not in the right place. I may come back to this. Oh, I am totally not in the right place. Bear with me a sec. Let's try this. All right, now we're cooking with fire. All right, so now let me try my sneak container. Let's see what the kind of feedback we get here. Come on, Sneak, you can do it. All right, we're in the vulnerability stage. There's a lot of vulnerability, so it might take a moment. Again, tempting the demo monster. We'll give it another moment and then we'll bail. Aha, okay. This is the output I was looking for. Sorry it took us a moment to get there, but here we go. So now this is we're kind of outside of JavaScript now, but you could get this kind of feedback with JavaScript and Node. This is Java and Tomcat. And what I wanted to point out here, the reason that I wanted to run this is in the base image that I'm using, there's 735 vulnerabilities. This has nothing to do with my application. And notice that 70 of them are critical, 196 are high. This is really bad, right? But if you look at the recommendations here, if I am willing to switch, or if I'm able to switch to a different version of Tomcat, if I can switch to Tomcat 10 in this case, or we might imagine going from Node 8 to Node 16, my vulnerabilities drop down by an order of magnitude to 16. And more importantly, I have no critical and no high vulnerabilities. So when we're working with containers, we want to, just like with our open source libraries, we want to have a high degree of confidence that our containers are going to be safe. And in this slide, in this example, we have a similar dynamic with Node. And we can see that the current image of Node has 975 vulnerabilities. But if we simply upgrade from version 10 to version 16, that drops down to 43, and there are no critical, high, or even medium vulnerabilities. They're all low vulnerabilities. So this would be a much safer environment to run in. And again, this has nothing to do with the application itself. This is just making sure that the runtime is safe and secure. All right, moving on. We have a bunch of really good resources here for Docker image security best practices, and we have a bunch of these for different contexts. We have these best practice resources, and you can see the URL in the bottom there. I'll see if I can drop it into chat before the end. I'll drop in a bunch of these resources into chat, but this is super useful in making sure that when you're working with Docker, you're using best practices from the perspective of security. All right, let's look at the last layer. The last layer here is, what do you think it is? Anybody care to guess? And drop it into chat. Well, we looked at our code. We expanded the surface area of our application by thinking of the dependencies that we have in code. We expanded that surface area again in the context of containers, and we're going to expand it even once again when we look at the last layer of our iceberg. So the last layer is infrastructure as code, and those are your Kubernetes, Helm, Terraform, and it's kind of like containers on steroids. So we have the capability now to spin up 1,000 instances of a virtualized machine and have our code deployed to it. But now our surface area is expanded even further, because if we have a misconfiguration in our Kubernetes or our Terraform configuration file, that's going to be propagated out to all of these instances. So the NSA has identified the #1 vulnerability in cloud as misconfiguration. And we have some examples of that, where 77 million PlayStation Network accounts were hacked, 57 million customer and driver info records were breached from Uber, and this was from AWS credentials. And we see this happening quite a lot, unfortunately, where private keys, private credentials are published publicly. 119,000 scanned docs in a FedEx breach. So, and this was all because of misconfiguration or private things being made public. And if we take a look at a Kubernetes configuration like we see in front of us, kind of this is the low-hanging fruit example, and that is, by default, everything's going to run as root inside of Kubernetes. Now, this is an easily addressable issue. In most cases, your application doesn't need to run as root. And so with 2 lines of code, security context, run as non-root, we've now shrunk that surface area of attack simply by ensuring that all our processes that we deploy to this running instance are not going to be running as root. So this container that we're deploying to Kubernetes, this goof app, at least it's not going to be running as root. So that's very low-hanging fruit, but that's all through the IAC configuration. So if we look at this all together in the context of a modern application, something like 10 to 20% of your code base is application code, the custom code that you write. 80 to 90% of your code base are going to be those open source libraries. And we find that 80% of vulnerabilities come from indirect dependencies, that is, dependencies of dependencies. So if you're bringing in the marked library and you have a high degree of confidence, or let's say you're a contributor to that open source project, you have deep knowledge of the marked library, but marked has its own dependencies. And as developers, we can't possibly be intimately familiar with all of the transitive dependencies. And that's where 80% of the vulnerabilities come from. Now, with containers, there are hundreds of Linux packages, and their vulnerabilities kind of get dragged along. And like I used to tell my daughter, the internet is forever. So we have to be really aware of the versions of these container images that we're using. And we want to make sure that we're scanning them for known vulnerabilities and not just trust because they're on a public space like Docker Hub. We shouldn't just trust that they're safe because of that. Because just like we saw with marked, I can still use this old version of marked. We can have vulnerabilities even in public versions of container images. And then it's worth saying again that the #1 cloud vulnerability is misconfiguration. So we have so much power with these simple files that marshal up hundreds or thousands of instances of virtualized machines that we have to really make sure that we don't have these misconfigurations. So here's the thing. We say we want developers to become very security aware. We want them to have a security practice without them becoming security experts themselves. Because developers, we have enough to do already. We have to build features. We have deadlines. We don't need to go out and get CISSPs, but we can integrate a security practice into our development lifecycle. And there's a lot going on this slide, but everywhere you see patch is a place where you can test and fix and monitor. And so that you have a high degree of confidence that you're not going to be publishing applications with security vulnerabilities in them. So while we're coding, we can be testing, like I showed you in the IDE. In our CI/CD pipelines, we can have testing as part of that. So just like we have test suites for our code, we can run security scans, and we've become very accustomed to breaking the build if a test suite fails. Well, likewise, we can break the build if a security scan fails, so that we're not accidentally publishing known vulnerabilities out into the world. And then one of the most important things, and often overlooked, is active monitoring of our production environments. So if you were a Snyk customer and you had Java code running in production on December 9th of 2021, on December 10th, you would have received a notification from Snyk saying a new vulnerability has been discovered, and you have application code in production that has this vulnerability, and this is something that needs to be addressed immediately. So active monitoring of production is super important as well. So rather than thinking of the development lifecycle as kind of left to right, we like to think of it as this virtuous feedback loop where we take the learnings from the previous iteration from a security perspective, and we feed those back into the next iteration. So we want to constantly be scanning, getting vulnerability reports, fixing issues, and oftentimes it's just a matter of bumping a version to get the benefit of getting rid of those security vulnerabilities. So in summary, let's take a look at what we've talked about here, looking at defense in depth. So we want to inventory all of your open source components, and we can do that through techniques like SBOM, software bill of materials. We want to have a complete report before we deploy of our open source assets. And it's important that we do this before we build. This needs to be a live version of all of the dependencies of our application as we're working on it. Containers, low-hanging fruit. You don't want to run as root. You probably don't need it. You almost definitely don't need things like privileged containers. You want to make sure that you're using the least possible version of an image for your container. So the example I like to use is some container images have everything built into them. And maybe I'm deploying a Node.js application. Well, if I'm deploying a Node.js application, I don't need my container to have a Java virtual machine in it. So I can shrink that surface area of attack simply by removing utilities and frameworks that I don't need. So I want to have as slim an image as possible. You want to deploy from known sources. You want to make sure, if possible, that you have a read-only root file system. So if you're using a modern Apple Mac laptop, for instance, you'll notice that your root file system is read-only. Now, that can be a pain sometimes, but from a security perspective, that's a great approach because it's less likely that our base file system will get compromised. For IAC, you want to use secrets responsibly. You want to make sure that they're encrypted. You want to make sure that you're not publishing secrets to public locations. Unfortunately, that's a lesson that we keep learning over and over again. You want to make sure that you have a good security context in your runtime. You want to make sure that your network policies make sense. So this is kind of where we start bringing in DevOps to our developer practice. We want to make sure that we're not just throwing open all the ports that we don't need. And so as your friendly security advocate, I want to say you want to adopt a DevSecOps approach to your development practice. You want to have security just be a natural part of it, but still be able to move fast by using scanning tools like Snyk to have a high degree of confidence in all of your code all the way down that iceberg. Automating simple security tasks, so things like letting Snyk create automatic fix pull requests for you. Now, Sneak comes right up to the point of fixing your code automatically, but we want that human interaction for the last mile. So we'll create a PR and you'll get a notification that that pull request is created, but you still have to press the button that merges that code. Security training is really important for developers, and that can come in all kinds of forms, but it can even be lightweight where you go to Sneak Learn and you learn more about vulnerabilities or you learn more about best practices. All right, so to wrap up here, we have a bunch of really useful resources. So we have these cheat sheets for a whole bunch of things. So we have React security best practices, Log4Shell, NPM best practices. So these are all found at sneak.io/security resources. Let me drop that into chat and I'll see if I can drop some more at the end here. Security got to spell it right. Oh, almost didn't. Resources cheat sheet. All right, somebody do me a favor and double check that link. I think it's good. I can even pop it up on the screen here. So security resources cheat sheet, super handy. Sneak Learn is a great resource to learn about vulnerabilities, to go deeper on vulnerabilities. And it's a very guided, interactive sort of interface. So if you want to learn more about prototype pollution, we're going to show you through kind of a pseudo terminal that you can interact with what that looks like. We produce these documents from time to time, and we just recently released our state of open source security document. That is super useful. We also have our cloud security report, and these are both recent documents that have come out in the last few months that give you a lot of information about where we're heading. And some of the stats that I showed you come from these reports, like the average number of dependencies and the average time that it takes to patch vulnerabilities when they're discovered. So in wrapping up here with a couple minutes left, let's do, oh, great. Thank you for confirming that the link is good. Let me circle back and let's go and import a project live. So I'm going to add a project to my Sneak account here. And I have this one called Chat Goof. See if I can find it. And I'm just going to grab this one. Let's see. Actually, let me try this one. I forget what state of repair I've left some of these in. And it's going to do a scan similar to what we saw in the IDE just a little while ago. All right, so awesome. And let's go and look at the vulnerabilities we have here. So we still have a critical vulnerability. We have some high vulnerabilities. And let's see if, now I'm going to do this manually, but this is the kind of thing that Sneak can do for you automatically if you set it up that way. And we can say, fix these vulnerabilities. And I'm going to go ahead and open a fix PR just to give you an idea of what it looks like. Again, tempting the demo monster. I've been tempting the demo monster a lot. Oh, see, the demo monster really bit us this time. So this one was not successful. Let's see if I can go look at a different one. I want to end on a high note here. Oh, I know why this is. Hold on, bear with me a second. It's because I'm actively demoing things here, and I actually fixed this vulnerability. So we're just about at the top of the hour, but I'm gonna see if I can quickly do this because I want to end on a high note. Goofs, I think it's this one. Sneak chat goof. Yes. Okay. So source, front end, package JSON. Gotta spell it right. There we go. And let's Just make sure that I'm pushing this to the right place because I fixed this in line yesterday and I want to push this to the right place. So bear with me a second. There it is, dog-eared. Okay, so I'm going to say git push force dog-eared main. Don't do this in real life. You never want to do a force push. Thanks for hanging in there with me. We'll wrap up in just a moment. And I'm going to come back here and I'm going to retest. This will take just a moment, hopefully. Come on, Sneak, you can do it. All right, this is what I get for tempting the demo monster, but I'm not sorry. This is what happens. Okay, so here we go. Let's fix these vulnerabilities. Open a fix PR. Fingers crossed, last try. If this doesn't work, we're going to have to end not on the highest of notes, but I think it's going to make it. Come on, Sneak, you can do it. Huzzah! Okay, so this is what a fix PR looks like. We give you all of this information about the vulnerabilities that were found. We also give you guidance. In this case, we're saying, you know what, you should review this because this might include a breaking change. And if we actually look at the files that are changed here, we can see that it's upgrading from 0.35 to 4.0.10. That's the recommendation that it's giving us. And because it's such a big difference, it's recommending that we review these changes before we merge them, because it's likely that there's going to be a breaking change. Now, again, I cheated with this, but you can see that when you get this kind of this kind of feedback, it gives you a lot of good information here. I don't know about you, but I've never written this detailed a PR myself, but you get the direct links to the vulnerabilities. So super useful. So glad we were able to end on a high note. Thank you. Stay safe in your journey to cloud native application security. And thanks for joining me here this morning. I really appreciate it.